Okay, folks, this is another classwork problem that we looked at together. So this problem reads that the picture is showing us here 4/7 of a candy bar. All right, and our goal here is to draw the whole candy bar, or draw one entire candy bar. All right, the directions on the page said as accurately as possible, draw the entire candy bar. And it also said describe how big, describe your process that you went through to determine how large the actual entire candy bar was. All right. So that description, I'll kind of talk my way through it. With this course, as usual, as your 107A, you're going to be writing a lot of your explanations. So the things that I write, the things that I say, you'd probably want to be writing down at some point if this was a written homework. But just as a warm up, let's go. Okay, so what we're trying to do is draw the whole candy bar. So you might say, well, wait a minute. Step one of the definition of a fraction is establish the whole, right? And here, so we're given a fraction, 4/7, and we're being told to sort of identify the whole. It seems like maybe we're working in reverse. But that's okay. So that means this fraction is, we can interpret what this fraction means by ourselves stepping through the definition of a fraction, and then sort of fill in the missing pieces as we go. Okay, so there was one whole candy bar established, right? Somebody walked into 7-Eleven and bought a Hershey bar, and it was a certain size, right? So that was their whole candy bar. Then I'm going to assume they cut it with a knife, because this looks, or else they ate it, they nibbled it up, but it looks like a little perfect rectangle right here, and they ate a certain portion of it. And so what we know now is that there's 4/7 of the original candy bar remaining. Okay, so in class I kind of asked you guys which of these numbers I might approach first, and you might say, well, wait a minute, I've got something here, so let's split that up into 7 equal pieces, right? That seems reasonable because typically we want to split a whole into 7 equal pieces, but we had a whole candy bar, and we can imagine that whole candy bar as split into 7 whole pieces, right? In other words, this is not our whole. We can imagine that we had a whole candy bar split into 7 equal pieces, and then we've collected 4 of them. So that means this piece right here of the candy bar represents 4 out of the 7 pieces of our whole. So I could say, let's double this, right? If that's 4/7, then come over here, sort of estimate, right? So if this is 4/7 and I add another 4/7, remember, I can add fractions how we think we should add them because the denominator refers to pieces. So if I had a whole candy bar and I'm imagining that I split it into 7 equal pieces, then if I collect 4 of them and then collect another 4 of those pieces, I've got 8 pieces, right? So I could say, well, this is 8/7 of the candy bar, and so just cut off a little bit, right? But is that accurate? No, that might be a ballpark, so maybe we can estimate that the entire candy bar might be around there. But just as in the previous example, we want to be able to split things up and figure out exactly the size of this candy bar. So that estimation we will not do. But so what do we know again? Just to recap, we had one entire candy bar. We can imagine that it was split into 7 equal pieces, and what we see here is 4 of them. That means this is 4 equal segments. So let me try to show this as representing 4 equal segments. So I can split it in half, and then split each half in half, and I will assume for argument's sake that those are equal in segments. All right. If I want to kind of imagine this is a number line, sort of extend that a little bit, and I can put a 0 right here. And so what I've got then is this number right here, this mark would be 4/7, right? I collected 1, 2, 3, 4 of those 7s. So where is our whole going to live? Well, we saw in the previous example, and it makes sense that if we split our whole into 7 equal pieces and then collect all of them or eat all of them, then we've eaten the whole piece. So I need to identify where 7/7 is. So I know about how long 1/7 is. Let me use my TV remote control right here, and it goes to just about this little line. So I can kind of say maybe right around there, and right around there. So I'm trying to use something to measure, something without numbers associated with it, but something where I can kind of mark equal lengths. And so let's say I want to come over like this, come over like that, and come over like that, and maybe attach those pieces like so. All right. So let's see if this works. If this was really 4/7, then this should be 1/7, 2/7. So I can go ahead and label all these fractions on here 3/7. If I move 1/7 beyond there, I would have 5/7, 6/7, and then here finally 7/7, which would be 1 whole candy bar. Okay, so kind of working through the definition a little bit backwards. The first thing we looked at was how many pieces we collected because we had a portion of the whole and we were trying to identify the entire whole.